There are two ways of dealing with the industrial solid and hazardous waste. First is waste management and second is prevention of pollution and waste. In the first way of waste management, we produce large amount of waste which is an unavoidable part of the industrial and economic growth, and then try to manage the waste either by reducing it or by burying or burning or by landfilling it. While preventing pollution and waste is to produce less waste on the first place and then to utilize waste as a potential resource through several methods of recycling, reusing and reducing. In this approach, the economic system is used to discourage the waste production. It rather encourages the prevention of waste and use of energy and matter in a proper way, so as to reduce the unnecessary consumption. This approach gives more emphasis on reduce waste and pollution, reuse as many things as possible, recycle and compost, and less preference is given to chemical and biological treatment or incineration of waste that cannot be reduced, and burying waste in landfills or above ground vaults. According to scientific estimates, in a low waste society, 60 to 80% of the waste could be eliminated through reduction, reuse and recycling. Remaining 20 to 40% of the waste could be treated to reduce the toxicity, and the remnants could be burnt or buried. The present approach of most of the countries is that of the high waste production to achieve the maximum economic growth and the low cost of production, and then to manage the waste somehow. But slowly the approach of many small industries and corporate sector is changing, because these companies, they have learned that the reduction of waste and pollution can be good for corporate growth, safety and health of the workers and consumers and the environment as a whole. One way of reducing waste and pollution is to reduce the consumption of a particular product. Only when it becomes necessary, then to use the product, that too in smallest quantity. The other way to reduce the waste and pollution is redesigning. For example, to redesign manufacturing processes in such a way that less material is used. Today's new generation cars, for example, are lightweight because most of their steel parts are slowly replaced by the aluminum or plastic based products. To design products that produce less pollution and consumes fewer resources when used is also a way of reducing waste and pollution. For example, to design more energy efficient lights, auto vehicles and other appliances. Manufacturing processes can be redesigned to produce less waste and pollution. For example, most toxic organic solvents can be replaced by water based or citrus based products, and the hydrogen peroxide could be used in place of the chlorine, which is generally used for the bleaching of paper, textile and many such products. The green design concept and life cycle assessment is also a way by which the waste can be reduced or the pollution could be reduced. For example, some European car companies have designed their cars in such a way that they could be easily disassembled and the parts can be repaired, reused or recycled. Similarly, the tires have now been designed in such a way that their life cycle is 97,000 kilometers, but scientists and researchers feels that it could be increased to 1,60,000 kilometers by the remanufacturing or redesigning the product. Eliminating unnecessary packaging is also an important part of the reducing waste and pollution. Eco-industrial revolution is a new concept in which all the industrial products and processes are designed in such a way that they become integrated part of a closed system of material flow and cycling. In this concept, one company's waste becomes the resource of other companies. Besides, the companies also take back the packaging and the used products so that they can reuse, recycle, remanufacture and even compost the products. This is also known as the industrial symbiosis. One such example of industrial symbiosis has been established in Kallenberg of Denmark, where a oil refinery, a thermal power project, a municipal heating system, a sulfuric acid plant and biotechnology company, a few farms, a fish farm, some greenhouses, one sheetrock plant and some other business groups work together, and each company's waste is a resource for other company. Such eco-industrial parks are in planning in many countries including United States. Scientists and economists believe that this shift from dirty to the cleaner technology can be accelerated and can be achieved in next 20 to 40 years. Reuse is also a way of waste reduction through which we can keep the high quality matter resource from being wasted into a low quality matter waste. It reduces the energy consumption, extends resource supplies and reduces pollution. Industrial waste such as metal or salt based waste cannot be destroyed, and if improperly disposed can be a hazard to the people and the environment. These wastes have potential economic value and can be reused. Many precious metals like gold, platinum, antimony, tungsten and cobalt are routinely mined out from their waste, which has significant amount of these elements. However, few of the elements which are of less value like iron and aluminum cannot be recovered because their waste is of low value. Valuable element like silver can be recovered from the photographic waste. Industrial waste high in solvent can be recycled after the use, be purified and reused. For example, acetone, chloroform, benzene, xylene and hexane can be reused. Industrial wastes containing high amount of organic carbon forms have large quantities of stored energy, and these wastes such as organic liquids, the woody material, resins and oils can be used in incinerators and in electric generators for the recovery of energy. However, this type of reuse is not very eco-friendly and is governed by high air emission standards by Air Pollution Prevention and Control Act. Other industrial wastes such as mine tailings can be used for the fill and the earthworks, or the oil field waste, if made the salt free, can be used for earthworks. Similarly, coal burning waste such as fly ash can be used for the earthwork and in mixing the soil, and it can be also used for the making of bricks. Besides, many industries like soft drink, dairies and distilleries can make reuse of their PET and glass bottles so as to save the energy and matter. Another big problem of solid waste is that of used tires. Tire dumps are the fire hazards and they are the biggest breeding grounds for mosquitoes. The tire waste is reused in United States for foundation and wall making in the low cost housing. Recycling. Many of us are very much familiar with the recycling of common materials like aluminum, glass and paper. Recycling of aluminum is a good example because it produces 95% less air pollution, 97% less water pollution. Besides, it saves around 95% of the energy as compared to that which is needed for the mining of aluminum. There are several other examples of industrial recycling and reuse. For example, an oil refinery can refine the motor vehicle oil and reuse it. A paint manufacturer can process waste and household paint. A paper industry can recycle the reused paper, although it is a bit difficult process because large amount of paper which is produced nowadays is coated with plastic or some other kind of material. Recycling of metal and glass can be continued indefinitely, but the recycling of plastic is not possible because after several use it loses its quality. However, the reuse is more eco-friendly and it causes less pollution as compared to the recycling. Industrial waste can be treated to achieve two major goals. First, to reduce the volume of the waste, and second is to reduce the toxicity of waste. Waste treatment can be done through four major processes, which are chemical treatments, thermal treatments, physical treatments and biological treatments. Chemical treatments. This includes the treatments like neutralization, precipitation and oxidation. Neutralization is a process in which the acidic and basic wastes are treated so as to make them neutralize and to make them non-hazardous and non-reactive. Precipitation is a process which is often used for the wastewater and slurried sludges which contain metal. In this process, a substance is added to these waste so that the metal becomes insoluble and it precipitates out. Oxidation is often used to detoxify and destroy organic pollutants of carbon based waste streams. It is of two types, the thermal oxidation or incineration and chemical oxidation. This includes incineration and oxidation. Incineration or thermal oxidation is burning of waste at high temperature. Solid or liquid organic containing wastes which have the high energy value and low water content can be good example of treating the waste in this way. But this method is hazardous because in this method a lot of hazardous air pollutants are produced and the toxic ash is also produced. It is a process which is used for the metal based waste. In this process, the waste is chemically or physically treated before its final disposal. In thermal stabilization, the waste is heated to high temperature and melted. After it cools, it is converted into a hard mass in which it is difficult to leach out the metal. Thus, it can be safely disposed into landfills. This includes the treatments such as filtration, dewatering and drying and distillation. In filtration, a liquid is separated from the solid through a membrane. Dewatering and drying is popular method for treatments of slurry and wastewaters. There are several options available for dewatering and drying, which includes air drying, particle filtration, sedimentation and decanting. Distillation is used to separate the mixture of liquids through using the temperature. In this method, the resource recovery is done and it is used to reduce the volume of waste. It is also known as bioremediation. Here, the microorganisms are used to convert the hazardous toxic material waste into the less hazardous and non-toxic waste. The microorganisms, they use this material as their nutrient, and sometimes even they change the toxic metal waste into the less hazardous or non-toxic metal waste. When plants are used for this process, this process is known as the phytoremediation. In this process, many microbes and plants are used, and even the genetically engineered microorganisms are being used successfully for bioremediation. Disposal is the last step in management of industrial waste. Industrial waste that are having the low metal content and have low economic value are disposed through landfills. But before dumping these wastes, it is necessary to neutralize and stabilize them so that the toxic metals do not leach out. Similarly, wastes high in salt contents can be dumped into special landfills. Another method which is used in developed countries is injecting the waste into deep underground well within well understood geological formations. Generally, liquid wastes of oil refineries, the brines, metal containing waste, wastewater and wastewater containing high concentration of organic toxic metals can be dumped through this process. This includes pesticides, radioactive materials, the chlorinated hydrocarbons which are disposed by this method. These methods of industrial waste disposal are not very safe, and if there is a leakage or seepage, then they pollute the groundwater and other resources for at least 10,000 years. Therefore, complex and costly regulations in addition to the potential liability limits such disposals. Besides, identifying a site for disposal of industrial hazardous waste needs a lot of regulations and investigation. Continuous monitoring is required of the dumping site so that even after disposal of waste, there is no harmful effect on the man and environment. Today's developed countries have evolved a new method of getting rid of their waste, and that is to export waste to the less developed countries and the poor countries. More often, the whole process is done to escape the strict regulations and the local opposition of the people and to save money. Most of it is exported to the Asian countries and the European countries, including Russia. In recent years, a large amount of electronic waste has also been dumped in these countries. This e-waste is highly hazardous and its disposal is not safe. It is evident from this discussion that most of our industrial processes are not safe, and we have to redesign them so as to produce less pollution and environmental safety. Also, there is an urgent need to address our present model of economic growth in which least attention is given to the human health and environment issues. To achieve a zero waste society, it is necessary that we use green technology which is environmental friendly and long lasting.